All right, I'm going to talk a little bit about the p-value here. So first, and actually in this segment, I'm just going to give some definitions, help to understand the concept. So here, just reading, this is from the American uh, Statistical Association. It says, informally, a p-value is the probability under a specified statistical model that a statistical summary of the data would be equal to or more extreme than its observed value. So that summary is a statistic. So what's the probability that you would get a statistic more extreme than the one that you actually observe in practice? So you might think of a t statistic or a z statistic, one of those things. So another definition, this one from Anderson et al., is a p-value is a probability that provides a measure of the evidence against the null hypothesis provided by the sample. So smaller p-values indicate more evidence against the null hypothesis. So p-value is going to tell us something about probability, but it's giving us some measure of evidence relating to the null hypothesis. So just a little different way of thinking about that. Some other thoughts about a p-value, just trying to understand what it is. The p-value is the probability, so again, we're coming up against this probability concept here, that randomization alone leads to a test statistic as extreme as or more extreme than the one observed. So again, we observed something. Let's suppose we have a test statistic. It's a t statistic. It takes on a value of 1.5. What's the probability that we would have gotten that just by chance, as it were, randomization, as opposed to, we can think about another thing. If this isn't random, what would be going on? Maybe it's that the null hypothesis is false. So another comment on this, again from Ramsey and Schaefer, is the p-value for a t-test is the probability of obtaining a t-ratio, so the statistic there, as extreme or more extreme than the t-statistic in its evidence against the null hypothesis if the null hypothesis is correct. So under the null, assuming the null is true, what's the probability you would obtain the test statistic that you did obtain, or something even more extreme? So again, following up on this, maybe there's some slight differences in the way these are worded, but p-value, or attained significance level, is the smallest level of significance, alpha, for which the observed data indicates that the null hypothesis should be rejected. So that one's worded quite differently than the previous ones. It doesn't even make a reference to a probability, but it tells us something about when we might reject or fail to reject a null hypothesis. So here, just say that the p-value represents the observed probability of committing a type 1 error when rejecting the null hypothesis. So we can only commit a type 1 error when we reject the null hypothesis. That's worked into the definition of what a type 1 error is. So an example here, if we had a two-tailed test, suppose we get a test statistic of 1.78 that has a p-value associated with it of 0.0823117. Now that, though, takes place for a certain number of degrees of freedom. If it's a t-test, if it's a z-test, degrees of freedom don't enter in there. But if you reject the null hypothesis, what we're saying then is the probability of committing a type 1 error is 0.0823117. Now, you might take exception to that comment. You might say, well, the null hypotheses, they're true or false. There's no probability associated with it. It's either 0 or 1. So here, thinking about being a little bit more liberal or generous with our interpretation of what this is meaning. And so what do I mean with this? If the null hypothesis is true, and 100,000 researchers collect random samples, and they're all the same size as yours. Let's figure this is a t-test, let's say. Then about 8.231, so that came from up above there, of them, or about 8,231 out of these 100,000, would get a test statistic more extreme than what you found, the 1.78. So even though the null hypothesis is true, there's still going to be some random samples collected, some resulting uh, test statistics coming from those samples that are far away from uh, from zero. And those, if they're far enough away, of course, those are going to lead to rejection. So give some examples in a separate video.